So, big deal. What's the point of all of this? We've got an RDD in a slightly different structure to the RDDs that we've been working with before. But what's the point of all of that? Well, the point of it is, if we have a look at this pair RDD, we'll find there's a whole set of extra methods that don't exist in regular RDDs that allow us to do operations based on that key. For example, I can immediately see by using the IntelliSense that we have a method here that we haven't seen before called aggregate by key. You wouldn't be able to do that on a regular RDD. And there are quite a lot of them. I won't go through them all, but just a very quick scan down here shows quite a lot of methods that end with the phrase by key. For example, this one here called group by key. So remember, the object of this exercise was to count up how many warnings we have, how many errors we have, how many fatals, and so on. And I reckon one of these by key methods is going to be useful. Let me show you one of those methods, and that's called group by key. Now, I'm showing you this one because I think it's one of the easier ones to understand. However, I am going to flash a warning up at the bottom of this caption. It's a little alarming that it's in red, never mind. And I'm warning you here that group by key is easy to understand, I hope you'll agree, but it can lead to severe performance problems on real-world data. It's not just performance, in fact, it will often cause crashes to happen on your cluster. Now, I'm not going to go into the details of why that's the case just yet, because we have a separate chapter devoted to performance, and I just want to get across the API first of all. So I've just chosen this one really because it's, I hope, simple to understand, but actually generally you would want to be looking for a better alternative than group by key on real-world data. As I said, plenty coming up on that a bit later in the course, but if we call group by key on our pair RDD, then a transformation will occur which will create a new pair RDD, and the new pair RDD is going to look something like this. There will be just one entry for each key in the resulting RDD. But for each key, the value will be a collection. It's actually just going to be a standard Java collection. And I'm just denoting that here by the square brackets. And the values in that collection will just be all of the values that existed previously, but now they've been grouped together under the one entry for the key. So I hope that's understandable. And it would mean that once we've got this new pair RDD, we could just go through all of the keys and count up how many values there are for each of them. Now, apart from the performance problems with grouping by key, one reason that I don't really like working with group by key is that what we're going to end up with when we've done this group by key is a pair RDD, and the keys in this example are going to be of type string. But actually, the type of the value is a little bit awkward to work with. You might imagine that the type of the value is going to be a Java collection, something like a list. Now, a list would be really useful because we could just call the .size method on it. But actually, as you can see from my caption here, the type of object that we have in here is a Java type called iterable. In fact, all collections in Java implements the iterable interface. And the idea is that any collection that you have that you can do an iteration on, in other words, you can use it in a for each loop, needs to implement this iterable interface. Now, because I'm not the designer of the Spark API, I don't know why they've chosen to return the type iterable. But the annoying thing about iterable is, although when I've got this value, I can loop around it, I can get all of the elements out of it, but I can't easily just call size. Now, that's what we're really wanting to do in this exercise. So it proves to be quite awkward to work with these iterables. So for that reason, together with the fact that in practice using group by key will very often cause you catastrophic performance problems, which we're going to describe in full later on in the course, I'm going to leave group by key for now. Just if you're really wanting to use it, what I will do is at the end of this chapter, I'll return to show you how you could have used group by key, but only if you're interested. I'd rather show you immediately what I think is the best way of counting how many of these warnings, errors and fatals that we have. And the answer is to do a reduce. I know you're familiar with reducing. We saw previously that you apply reduce to an RDD to crunch that entire RDD down to one single value. Well, with a pair RDD, we can do something similar but richer. Now what we could do is we could construct our RDD slightly differently, because actually we don't need those dates and times just to count how many of them there are. So I'm going to suggest that we change things so that we have the keys as normal, but for the values we're just going to have the value of 1. You can probably see where I'm going with this, because previously we used this trick to do a reduction which would give us a count of how many values we had. Well, we can do something similar in a pair RDD, but the difference is the method this time is called ReduceByKey. For the parameter, we supply exactly the same kind of reduction function that we used before. For summing, it's just going to be given value 1 and value 2. We want the reducer to add them together. But the difference is in the implementation. You can probably guess what's going to happen here. All of the warnings are gathered together, and then the reduction operation is applied to just the warnings. So we will get an answer for the warnings, but then the errors are gathered together and the reduction function is applied across those, and then the warnings and all of the other keys. So the keys are gathered together individually before the reduction method is applied. So what we're going to end up with as a result of running this method is we're going to end up with another RDD. It's another pair RDD, but this time of type string, with the values being integers, because the integers are the results of those reductions, which in our case, which is a count of how many instances of each key there were. It's quite similar to doing a grouping, but there's a good reason why this in general will perform a lot better than doing a group. That's coming up in the performance chapter, but this is perfect because this is exactly the results we were looking for, and it's going to perform well, and we don't have to worry about that nasty iterable that we saw with the group by example. Hope that's reasonably understandable. As always, probably the best way to understand it is to try it in action. So the pair RDD as we have it at the moment contains strings, which is the level, and the value is going to be the date and time. Well, we've seen we don't need this date and time anymore, so we're going to change this now to be, well, actually I said an integer on the caption, but it would probably be better as a long, because this is a terabyte file and we're probably going to have maybe trillions of these log messages. So a long would be better. And instead of getting the date, we're really not interested in the date, so I'll delete that line. And in the tuple 2, instead of the date, we will return the value of 1, but expressed as a long. So that means we can now, on this pair RDD, we can use this new function which would not be available on a regular RDD. We can use ReduceByKey, but it's no more complex than the regular reduce that we used before. Given two values, value 1 and value 2, the reducer in Spark needs to take those two values and add them together, and Spark will apply that reduction in exactly the same way as we've seen before, but with the difference that it's going to group them by key. So that's going to give us another pair RDD, strings being the keys, that's the logging level. The values will be long again, but this time it's going to be the sums. So to finish off, it would be good if we could print the results out. So we'll use the same trick as previously. We'll use the for each method, and for each value, now we've got to think about what we want to do here. Remember that each element of a pair RDD is a tuple. So the elements that we're going to be given here are a tuple, which we can pass into the system.out.println method. Now, something I didn't tell you in the chapter on tuples, if you want to extract the elements of the tuples, if you hit the dot on the tuple, well, there's an awful lot of rubbish in there, but there are two fields that you're able to access directly. These are just public fields inside the tuple. We're not calling methods here. And the fields are called _1 and _2. Definitely doesn't feel very Java-like, this, but I hope it's obvious that the _1 is going to be the first value in the tuple. For us, it's the key, and that's why it's of type string. And the _2 represents the second value, which for us is the long, and that's going to be the count. So we can do something like then, we'll output the value of tuple _1, tuple dot _1, which is the log level, and then we'll concatenate this into a string where we will also output the tuple dot _2, and we'll add on and we'll say that has that many instances. Now, I'd like to clean this code down a little bit, but before we do that, we ought to see if this works. Let's give it a run. Again, the output's slightly skewed because of this logging, but we are seeing that errors have 2 instances, fatal 1 instance, and warnings have 2 instances, so it looks like the count was correct.